period by using the formula P equals 2 pi over B, but I don't have a formula this time. I don't have an equation, so I do not know my B value. How can I find my period given just this graph?
Oh, just count from the next time that it's the same.
Very good. Count from critical point to critical point, peak to peak, valley to valley. So in this case, I'm going to count from here to here. So it goes from a half. These are, by the way, the grid lines are halves. It's going from a half to 6.5. So the period is 6. Okay, so we identified our D value was 35 by counting up to the dotted lines. Or we got our A value from going dotted line to peak. So that was 25. Now I know my period is 6. Now, you're going to have to calculate your B value using the same formula that we were using yesterday. So P equals 2 pi over B. So my period is 6 equals 2 pi over B. And then you just calculate. So I'm going to clear the B. This is a fraction. So now I have 6B equals 2 pi. Divide by 6. So B is pi over 3. Okay, so now I have to figure out my phase shift for cosine first. So cosine usually, when we look at the cosine parent function, there's my cosine parent function, it starts on a peak on the y-axis. Peak on the y-axis. Well, this one, is my peak on the y-axis? No, it's been shifted over. How far? Just a half. So that is your phase shift. This has been shifted a half. Now it's been shifted to the right. Positive or negative half? Minus a half, right? Because it's shifted to the right. So it's a half. So when I plug all this in, my A value, my amplitude goes in front. B comes next. C is your phase shift. Okay, for sine, everything's the same, except the phase shift. For sine, the middle value, that's not a peak or a valley. It's a middle, and it's a middle going up. It's a middle value, and it rises from there. So I need a middle value that rises. Now there are two. There is a middle value that rises right here, and there is a middle value that rises right here. Either one will give you the correct wave. So it really doesn't matter which one you use. So if it were me, I would choose the one that is closest to the y-axis, which would be this one. So that has been shifted to the left 1. So that would be plus 1. So 25 pi over 3. This is now plus 1 and 35. If you were to put both of these equations in your calculator, it would draw one graph. It would actually draw two, but you wouldn't see it draw the second one because it would draw right over itself because they are the same graph. Everybody okay? Okay, try this one and see what you get. I'll give you a few minutes to fill in, and then I'll do it, and we'll see how close you get.
But what if I don't like it?
Where were you?
house.
You have to watch the video because for some reason these graphs didn't print. There's graphs there and they didn't print. These, they just didn't print. So you have to, it's on the video. Oh, I'll send you the video. Hold on a minute.
Approximately though.
Yeah, it's hard.
I might. Hey, that's pretty good. Eventually.
How do you get, I'm sorry, I'm just from having, how do you get C for sine?
The same way. You're looking for a middle. It's a middle that goes up. This is what sine is.
Hey, that's pretty good.
Yep.
Why would you not learn?
Because that's going
You know
down.
it's not gonna win.
And sine doesn't go up down. Remember, it's the snow.
Anybody want to try?
Oh, what's it?
I know, I said.
That's what he said. You gotta go for some. He feels the burn. As much as I don't care. I know that
And then I gave,
I would rather have burning.
then I gave you the notes.
I really thought everybody would.
Yeah, you need this over.
Rather have
I
burning.
I finished the notes.
So?
She's just an awkward black.
And I think there's a,
I hate how, like, when she speaks to people themselves.
There's a video.
She has speaks, so
I
they're
can't
not
remember, there was one day that the video was like,
She's faking it. She's trying to win.
So this is for.
It's something that George W. would do. He would like go to Texas.
No, but
and
I
sound like
know.
he really
I
sucked
will, but.
whenever he was in Texas. So, Ted Cruz is Canadian.
He's not eligible.
okay, D is 5, A is 15.
You better hope he's eligible.
A's 15?
No, review.
Period if you count.
They're also arguing.
You better hope.
He's eligible.
Oh, man.
And period is 4. Oh,
That is.
Oh my God. Wait,
Wait, what did you
no,
say, B1?
in Kasich might.
She actually done the.
Both of them were declared. Yeah.
I'm alright, I didn't find it.
okay. Your D value is 5, because that's where the dotted line is. Your A value is 15, that's dotted line to peak. Your period, I counted peak to peak, but you can count valley to valley, doesn't matter, is 4. B, you will have to calculate using the formula, P equals 2 pi divided by B. My period is 4. Clear the fraction. So 4B equals 2 pi divided by 4. So it looks like B is half pi. Alright, so I'm looking for a phase shift for cosine. So I need a peak. Now in this case, I have 2 peaks that I could use. This one or this one. It doesn't matter which one you use. And in this case, they are symmetrical. They are exactly the same distance from Y. So it makes no difference which one you choose to use. You could use -2 or you could use +2. It's going to generate the exact same graph since the graph is continuous. So it doesn't matter. I'll use this one, which is -2. It doesn't matter if you use the other one. So 15 is your A value, pi over 2 is your B value, -2 is your C, and 5 is your D. Okay, now we need to shift, find your phase shift for sine. Remember with sine, when you look at the sine parent function, you are looking for where it goes from a center up. So I need a center point that goes up. This is not a center point that goes up. This is a center point that goes down. This is a center point that goes up. So that's the one I'm going to use. That would be to the right 1. I've shifted right 1, which would be minus 1. So this is 15 pi over 2 minus 1 and 5. Everybody okay? Kind of, sort of? Alright, next question. Now there's no picture or function, this time just a table. But they do give me a maximum and a minimum point. If I can calculate the difference between the maximum and minimum, then I can figure out my amplitude. Because that, from the peak to the valley, is 2 amplitudes, right? It's all the way. So I can just half that and get my amplitude. So how far is it from the peak to the valley? 12. Which means your amplitude has to be 6. So your A value is 6. Once you know that, it's super easy to find your D value. You can either count from the valley up or from the mountain down. In this case, valley up is pretty easy. -4, add 6 to that, and your D value should be 2. Well, looky there, what they gave me on my table. These 2's. That's your central axis. So they gave me these central axis points. That's going to come in handy in just a second when we're looking for our phase shift. But before we do that, let's figure out our period. So I need to go from peak to peak or valley to valley. Doesn't matter which one you choose, but on this table, they don't give me 2 valleys. But they did give me 2 peaks. From 8 to 8. So remember, you're looking for the shift, or the period is your x values. So that would be from pi over 3 to pi. How far is that? Pi over 3 to pi, close. Pi over 3 to pi, 2/3 pi.
Oh.
Now again, we'll have to calculate our b value using our formula. Period equals 2 pi divided by b. So that's 2 pi over 3 equals 2 pi over b. Cross multiply. So I get b equals 3. Alright, now, this is where this one gets a little bit confusing to some people. I need my phase shift. So remember, if we're talking cosine, cosine has a peak on the y-axis. So wherever my first peak occurs, that's going to tell you how far cosine has shifted. So if you look at your table, your first peak is right here. It's normally where x is 0, and now it's where x is pi over 3. So it has been shifted pi over 3, but it was shifted right, so we're going to do minus pi over 3. Amplitude is 6. B value is 3. Your phase shift is minus pi over 3, and your D value is 2. Okay, now, sine. Sine's a little different. We're not looking for a peak or a valley. We're looking for a midpoint, something on the central axis that goes up. So remember, when we first figured out that our central axis was at 2, I pointed out that there are several of them. There's one here, there's one here, here, and here. All of those points lie on the central axis. I need one of those that goes from the central axis point, and the next place it goes is up. Because remember, sine is the snow of the snow cone. So it has to go up from there. So can it be this first place?
Yes.
Goes from 2 to 8. So that can be your sine phase shift. It's normally at 0, and now it's at pi over 6. It's to the right, so we'll call it negative pi over 6. So 6, 3, pi over 3, I'm sorry, pi over 6, and 2. All right, you try number 12.
value is plus 3?
Mm-hmm. Wait.
Because you put 1. Like, could you use...
Yeah, it's gonna work. Either one. If I put -1 on this one, because these things are the same. A central point that goes up and a central point that goes up. So it'll work. You could also put -5 or -9 or any of those will work
Okay.
because it produces the same graph.
Set the limit, set that up.
I think they actually want you to generate a table though and use 4 sum because they want you to use a Riemann sum. So plug that in your calculator.
And I'll use
And then pi over
quarter
4.
pi.
Yeah, quarter pi.
Yeah, I'll do it. Not now. I did the front page, but
Willis, put it in your calculator. Where's your calculator? Do you want to borrow mine?
no, it's in my bag. I have it. I have it.
Mine's right here.
Do it right now.
This one wrong.
Do it when you smell. Yeah.
It hurts. I'm not super strong. Independent man.
All right, so if I count from my peak to my valley, how far is it from peak to valley? 8. So what's your amplitude?
4.
4.
Wait, hold on. Oh, no? Wait,
Minus 3.
8, yeah, okay.
Okay, so my amplitude is 4. So I can go from valley up and get my D value is 7. Is everybody okay? Yes, sir.
Okay, D value. How do you get that down?
The D value is your central axis. If you have a peak and a valley, where is it going to be?
Oh, in the center.
Oh, okay, okay.
So it's just in between 11 and 3?
Now, personally, the way I do it, I figure out how long that is. It was 8. My amplitude is 4. So I go to the valley and count up. 3, 4, 5, 6, 7.
Oh, okay.
Instead of using the midpoint formula or getting crazy like that, I just count. Okay, so then the next thing I need is my period. Peak to peak, valley to valley. We'll go peak to peak because there's a peak and there's another one. So I need to go from -3 to 17. How far is that? 20. From -3 to 0 is 3, and 0 to 17 is 17. So altogether that's 20 spaces. Okay, so now you can calculate your B value. P equals 2 pi over B. 20 equals 2 pi B. Clear the B. Divide by 20. So your B value ends up being pi over 10. Alright, I need a cosine shift. Looking for the first peak. Well, that's easy enough because it's right there at the beginning. So it's -3 though, which means in my formula it's got to be +3.
Wait, how do you find the C?
Okay, this is cosine. And remember, cosine starts at a peak. So my table started at a peak. But it's not a 0 like it normally is. It's a -3. Which means it's been shifted left 3.
Alright.
Which means in my equation it has to be +3. Alright, now sine. I need my first central point that goes up. So I'm going to identify all my central points again. They're all on the D, remember? That's your central axis. I need the one that goes up. So this first one that I have, 2, 7, from that 7, it goes down to 3. That's not how sine goes. Sine is the snow of the snow cone, so it needs to go up. So 7 to 11, that's the one I need. So there's your shift. It's usually at 0. Now it's at 12. So it's been shifted right 12. So that's going to be a -12. So that would be for pi over 10, -12, and 7. Alright, you can keep that page. We are now going to apply it to real life type stuff.
You keep making like sound effects.
Alright, so, as in here, I put it to auto to ask, and then I put in power before, and it got me a really big decimal. Is there any way I can get that to an approximation? Like, I copy and paste it to the scratch pad, and then enter, and then it really did give me decimal, and then do like a, I don't know.
Oh, you mean, you wanna,
I want a fraction,
Is that gonna be your new everyday
says, or I could just put,
you know what? Just put that there. You know what, I'll do it. Hold on. Well,
no,
I did tell you to put it in the calculator, but then I just realized you're not gonna get exact answers. And you want exact
I
answers.
don't.
Yeah, I did too, I want exact answers. So actually calculate, hold on, I have more of those worksheets.
No,
They're blue because somebody had blue paper. So somebody gets a blue one. You want a blue? Yeah, that's good because I don't think blue will show up here anyway.
Okay.
I'll trade you. It's okay, you can put your name on it.
Is your hand feeling better?
It feels a little bit better and then I'll do something stupid. You want blue? No.
So,
Then I'll do something stupid
I'll take a
and it
blue.
hurts again. So, but I think it's getting
I have it written on mine.
I'm imagining that it's getting better.
It's just harsh.
Okay. So here we go. This is real life. This is how these things play into real world situations. Powering a combustion engine, fuel creates tiny explosions, push a piston up and down a cylinder, crankshafts turn, pushes the piston up, and the cycle starts over again, repeating many times every second. I mean many, many times. So suppose the up and down motion of a piston in a running engine can be modeled by this function, where t is time in seconds. D of t gives the displacement of the piston above or below its level at rest. Here's the piston. Here's a picture of the piston. Here's a picture of the pistons on the cylinder. I don't know anything about engines, do y'all? But I watch TV. You know what's so funny? Earlier today, I was like, I don't know anything about engines, do y'all? And they were like, no, Travis does. I was like, oh, well, good. But I watch TV, and on TV there's a commercial. I think it's for Pennzoil, and they show this, like, to show like that the oil makes sure go like they're supposed to. So that's what that is. It is modeled by this particular function. Okay, so the first question is easy. What's the amplitude of this function? 3.8. Now, the next part maybe not quite as easy. Interpret this in the context of this problem. What does that 3.8 mean?
That's
The
the distance from the center.
From the center up and the center down, the piston travels 3.8 centimeters up and then 3.8 centimeters down. So I'm going to put 3.8 centimeters.
Just an eraser.
Okay, so now, what is the period of this sinusoidal function? Well, they gave me the function, so I'm going to use my formula, P equals 2 pi divided by B, to find my period, because now I have a B value. The B value is 50 pi, so I can simplify, pi's cancel, and that simplifies to 1/25. Now remember, in this, period represents, on our notes page we said the distance from peak to peak. In this situation, we're talking about x values, the distance from this over here to over here, are your x values. In this particular situation, it's not x values anymore, it's t values, or it's time. So that is your period, 1/25 of a second. So then it says, interpret this in the context of this problem. What happens in 1/25 of a second?
The piston goes up, down, and back.
Up, down, and back where it started. It completes a full cycle. So if we were using a sine wave, it would start in the center, go up, middle, down, middle, and be done. If we were starting with a cosine wave, it would go up, center, down, center, up. But either way, it completes an entire cycle. Piston goes both up and down.
So wouldn't it be B equals a VP? Because
It's because it asks for the. The piston goes both up and down in 1/25th of a second. 1/25th of a second, it goes both up and down. That is really fast. Although it's not really as fast as you think, because if the piston completes an up and down cycle at this rate, how many revolutions would the crankshaft turn per minute? Now think for just a second. It completes one cycle in a 25th of a second. So how many cycles does it complete in a second?
40.
4.
No, 40.
It's,
No,
wait, 1/25th?
I don't know.
1/25th. Thank you. 25.
I thought you said 20.
One cycle is 1/25th. So 2 cycles is 2/25. So 3 cycles is 3/25. So 4 cycles is 4/25.
We get it.
So
I'm sorry.
how many cycles does it complete in a second?
25.
25. So if it completes 25 in 1 second, how many will it complete in 1 minute?
1500.
25 times 60, which is 1,500.
That makes sense because that's like an idle.
That is, okay, so now this is when I said 1/25th of a second is fast. But it's not all that fast, because Travis just said, that's when your engine is idling. Now, they never said that this was a car engine. So this could be an engine of something much smaller. And that might be as fast as it goes. That's what I said earlier, like a small tractor or like a moped or something like that. But your car, when your car is operating, it is going at much more than 1,500 RPMs. So, I mean, 1/25th of a second sounds really fast to me, but. Okay, so now it says determine a good graphing window to view several cycles of the function. So we're going to put this in our calculator and look at it. You need to be in radians. I know that because of the pi. It says 50 pi, so I know that that means that there's a radian involved.
What the?
Okay, now remember, here's where you have to be real careful when you're adjusting your window. Because, remember, our x value is now time. And currently, I'll show you, look how crazy mine looks right now.
Oh.
Look at that, look at that craziness. And it's because my x values, hold on. Oh yeah, look at that, that's insane. Okay, that's because right now my x value is set on 5. Well, we just said in 1 minute it goes 1,500 times. So in one, right? Yeah. So now in 5 minutes, how much is it going to go? A lot, which is what I've shown my window. So I don't need a number near that big. As a matter of fact, 1 cycle completes in 1/25th of a second. So if I wanted to see, let's say, just 1 cycle, I could go to my window, and I could go from 0 to 1/25th. And that will show me just 1 cycle. Look at there. So that shows just 1 cycle. But this actually said it wanted to see several cycles. How many cycles should we see? How many y'all want to see?
3.
Okay, so let's do 3/25ths, because that should show 3, right?
Yeah.
Oh, look at there. Isn't that cool? So your window, you have to be careful how you set your window. Because in order to see it, I had to make my window much closer up. I had to zoom in. Okay. Now, down here, in order, it says many engines run on 4 cylinders. That means it has 4 pistons attached to the crankshaft. They have to be engineered where they rise and fall at even intervals. They have to be evenly spaced so that the engine runs smoothly. So this shows all 4 cylinders on the same graph. What we need is to change our sinusoidal function so that we can fit all 4 on the same crankshaft. Has my amplitude changed any?
No.
Has my wave gotten fatter or skinnier?
No.
The only thing that happens is it is shifted over. So we have to shift it over the same interval 3 times. So we need to kind of figure out what that might be. So I'm going to hit tab.
Yeah.
The 3.8 does not change. Sine does not change. 50 pi does not change. I am going to put another set of parentheses, and I'm going to do x minus and shift right. I mean, you can shift left if you wanted to, but I'm going to see if I can find this 2. So, I know what it is. So, anybody want to guess something?
Minus 1
yeah.
over 25.
Minus 1/25th? Okay, we can do that. Huh. What did that just do?
It pepped it up. It moved it over a whole cycle.
It moved it over an entire cycle. Shifted it over right on top of itself. So that's not it. Let's see. So what do I need it to be? Smaller, bigger? What?
Much smaller.
It's much smaller. So let's see. What should we make it?
1/50th.
Let's see if that works. Haha. That looks like we figured out. Did we figure out 2?
It looks like
Yeah.
Looks like we figured out 3.
And then go 1/100.
Okay, so we need half of that. So we did 1/50th, so we need 1/100.
And then 1/75.
Okay. I got whatever I got 2. And now we need 4. I think I got 2. Or maybe that's 4. I don't know which one that is.
1 over
It's one of them.
75.
So now we need 1/75?
Let's try that.
It's either going to be 1/75 or 1/125. I think those will be the same.
Oh, it is 1
No,
over
yeet.
145.
Darn it! That's not it.
145.
Okay. Yeah. Yeah. It's 170. 1 over
That's not it.
75.
What?
175 is 1 over 75 is smaller than 1 over 50. You're going backwards. Gotta go.
So 200?
No. You get what I'm saying?
No. What'd you say?
1 over 75 is smaller than 1 over 50, so you're going back. Like,
Right.
So you gotta go with something bigger.
Okay, so I did. What do we have already?
We
We
had
had 50 and 1.
one.
And I feel like this was that one. Try to.
I thought I just did.
Yeah, what numbers do we have
Wait,
right
it
now?
should be.
I don't know, that's what I-
No, can we
150
check?
works. That's just gonna. I think.
No, that's
It
not
looks
it.
right. 150 there.
150?
Yeah.
Can we?
I thought we already had 150. Maybe that's why I didn't
Yeah.
have.
50, 100, and.
Yeah.
You say something over here.
I didn't have. We were trying to.
Can we see like
I'm
what's
telling you.
on the
Yeah.
table?
Yes, I'm
Try
going
to-
to. 1 2
Yeah, try to- I had the original.
Oh, can you
I had
see down?
50. I had 50.
125, 160.
I had the original. I had 50 and I had 100. We tried to
It's
have
so-
150 and that didn't work.
I would have thought 1 over 200 because it looks like this is patterned.
That didn't work either.
declaring war on comedy.
That's so weird.
Try.
Squirrels.
Him,
One
we know
over
you know.
175?
Tell us.
Donald Trump will declare war
Tell
on.
Tell him.
Insert anything.
Wait a
I
second.
don't know.
Declare war on war.
That one just goes right
Yes,
over one I
Donald
already
Trump
had.
will declare war on war.
Y'all were the first class that's done it by fractions today. Everybody else did it decimals.
Wait,
Well, you always say to use fractions.
I prefer fractions, I just thought it was interesting. Okay, either way, your responsibility for tomorrow is to finish this. There's 3 problems. Some of them give the table. On the back you can see they give you a table. This one in the middle gives you the information, all of the information in the graph for the graph. So you have to graph this one. This one gives you both the graph and the table. So they're not too bad. If you'll just, if you get stuck, see me in the morning. I'll find it real fast.
I'm just imagining his presidency.
Is that one of them?
Sanders. I'm
What-
imagining
what
Sanders.
what?
What am I gonna do with this? With the
Maybe.
over?
One over 250?
Where am I gonna put it? Can you hashtag burn it? No.
Dang it.
I don't know. You could start a write-in campaign.
Did the other classes find it?
Yeah, but they use decimals.
What is
What
it?
if you won
That's
the presidential election off
0.25,
the write-ins?
0.5, and 0.75.
What if you won the presidential election off the write-ins? Don't you think that would be amazing?
Nothing makes sense.
Well, because you remember
What an
they
atrocious accent.
they're continuous, so there could be several answers that would produce the same result because
Yes,
they're continuous.
Donald Trump will sue the voters for not voting for him.
I think.
And then, when he bullies his way to the presidency, he will declare war on democracy.
Scores between 1 and 30, and one of them wants something else.
Yeah, ooh.
Well, scores between 30
his own
and
country.
1.
He had a
One
line
them
of
wants something
steaks,
between
he had
1
a
and 30.
line of alcohol.
So it's scores.
That's some very successful hotels. He's gonna build his own
But
America.
it's not fair.
If Trump wants to rule a country, he should just buy one.
Exactly.
How do you write in the? Oh, I thought you were going to say that. I'm sorry.
Do what?
I thought you. I did see you. What did you write in for the other 2? Like, because I tried putting in my calculator, it just overlapped each other. For y2 and 3.
Well, what did y'all put in?
Well, I put in 3.8 sine 50 and pi, and then I put x minus whatever. But that kept on like overlapping it.
I don't know what it was as fractions. I found it as decimals earlier, so my actual answers are
Well,
decimals.
just like, how did you put it into the calculator? Like writing it.
3.8
Uh-huh.
sine parentheses 50 pi parentheses x minus 0.25
Oh,
close
like
parentheses close parentheses.
50 pi parentheses close, or
No,
or
open parentheses x minus
1 over.
yep
Was it 50 or 25? Well,
50 up there. Close parentheses. There you go.
You're a true theater woman. I'm gonna come over here and you can give me feedback while you're,
I sew just
Sewing.
enough to make a costume to look at from far away.
that's good enough for theater.
That's exactly right.
Okay, office girl gets on the phone and says, can you send Bella, that's Miss Flores' daughter, and Ariana Regent, and Jessica Castanuela to the office. And this is probably about 2 or 3 minutes before I'm ready to start teaching. They finish looking at their answers from the day before, and so it's about 10 minutes into the period. So I said, okay, I thought maybe it was discipline or something. And they didn't explain how long it would take, so I just sent them, and then we start waiting, because 3 minutes later I'm ready to teach.
And they're not there.
And we wait, and we wait, and we wait. And it's because Miss Everett called them in to talk to them about FCCLA. When they got back, I said, okay, what took so, were you being, I thought they were being disciplined, as the kid said, it's probably because they were late to bed today. And I said, okay, and I thought, but that's odd, Miss Rush, I don't know, she just doesn't usually,
Keep them.
she doesn't keep them, or she doesn't bring them. I've never had to wait on kids for Miss Rush, so
No.
that means she's always does it, you know, well into the period toward the end.
Right.
Okay, so when they got back, I said, and plus, then 2 of them were sauntering down the hall. One of them got back earlier. And I said, so I was already just really in a mood,
Irritated,
very irritated. And I said, you shouldn't have, what took you so long? It took you a while to go coming down the hall. I need to start teaching. We are all waiting. I'm gonna be out tomorrow, and I told you I need to teach you this so you can do tomorrow's assignment. It was just a little extension on something. And they said, well, Jessica, who always is the first to take attitude and said, it was about, no, it was Ariana. It was about FCCLA, and I said, but you were called into the office, not into, it wasn't Miss,
It wasn't Miss Alcedo.
it wasn't Miss Alcedo, you were
It
called,
wasn't Miss Evans.
and I said, you were called into the office, I thought it was important. And Jessica goes, this is important, it's mandatory. And I said, you know what, Algebra 1 is mandatory.
Yeah, FCCLA is not.
Yeah, and I said, what, it was about what? And they said, it was telling us that it was mandatory that we had to get to San Angelo, and we had to get our dresses. So then I thought, wait, is this for Ariana's, quince? Yeah, I thought, and I still think it might be for her quince. And I said, who called you in? Actually, I said, and who called you in? Like that. And they said, Miss Everett? Miss Everett did. And I said, about FCCLA?
Yeah, that is. I can go and ask her.
Well, I've already sent her an email. When you,
And not to necessarily get angry with her, but just to say they lied. Say what? I mean, I'd be angry with her, but.
I'm angry with her too. Because she's already called them out about the quince before. But to do it again now, when I'm supposed to be teaching, I sent her a nice email that said, could you let your office aides know when they call to get kids out, to please tell us whether or not it's going to take a while. I said I had to wait on them to start teaching, and the class didn't really have anything constructive to do in the meantime. Yeah, that wasn't about an FCCLA matter. Because Miss Alcedo would never have them called out.
Not for that long, and if she did, she would tell you, but
Uh-huh,
we have to do such and such, it's gonna take a little bit, it's.
uh-huh. Yeah, that was her quince, and I just realized it while I was talking to you. So now I'm madder.
I don't know you that much now. But that's not.
Well, which meant they only had like 8, by the time I taught the page they were doing today, at first I had to prepare them for tomorrow, which was, you know, just review some things with them. But then by the time I taught the page today, they only had 7 minutes to work on today's assignment. And they're my only regular class to begin with. They take a while. Okay, I vented. I'm okay.
What did she say in your email?
She hasn't written back yet. I just said what about let your office aides know if they're gonna be out. And that was when I was still thinking FCCLA. And I thought, I'm not mad at Martha. If Martha was gone today and had left a message, please call these girls out, she doesn't know that they were called, you know, toward the beginning of the period. Not right
Surely,
at, but
But, I mean, why would they need dresses for FCCLA?
that's what I'm thinking. And I know that they've been to San Angelo before about the dresses, and I know that Bella and Jessica are in her quince. So, that's exactly what it's about. And I didn't get a reply yet. Actually, now that I realize the truth, she's probably nervous about it. She's not gonna answer me.
No, she probably not.